Okay, right. Okay. Okay, commonly used device for supply and exhaust system is exhaust fan, surface mounted fan. Exhaust fan is similar to the one that you have normally see in the kitchen or in the toilet. Surface mounted fan. You don't see basically you don't see the fan, like you just see the cover of the fan or cover of the ducting. But the fan is actually inside. It's hidden inside the ceiling, normally inside the ceiling. Remote mounted inline multi-port fan ventilator. Okay, so basically this one on the left is remote mounted. I believe this is remote mounted. The fan itself is not mounted to the ceiling itself, but far inside the roof space, the truss, the space inside the truss. And then on the right is basically this is the surface mounted fan. Basically it's mounted on the ceiling. Like I said, we only see the cover, but the fan is right behind the cover. Okay, and basically need some ducting, duct works to bring in the air to the outside or to the inside, depending on which system that you use. Okay, are you guys familiar with this view? I would say. Okay. Tailors, yes. This is Tailors, toilet inside Tailors. Okay. So sometimes when you see this kind of duct works, this kind of metal ducting, right? You might get confused now whether it's aircon or for ventilation. But of course, inside the toilet, you don't feel cold at all, right? So basically, it's for ventilation. They look more or less the same, but the difference between the air conditioning ducting or ductworks and the ventilation ducting is normally the grills lah. The grills normally looks a bit different for air conditioning. Normally it's round shape. Okay, and sometimes it's also in a square shape, but then the pattern inside is a bit different. Okay, and usually it's smaller. For aircon, normally we call this diffuser. Diffuser is smaller compared to the exhaust fan. Okay, so the fan itself is located here. One thing very good about Tailors services, right? The building services in Tailors, you can learn something from it. So you can learn when you get into the toilet, you can learn. You can look up and then you look at the pipings, all the pipes, the ducts, things like that. So basically the fan is here. It actually sucks in the air in the toilet through this ducting, through this grill here. So basically the stale air, right, polluted air inside the whatever smell inside the toilet actually gets in here, and then is basically carried through the ductwork, okay, and then exhausted or removed through this. There's an opening here, right? So basically, the opening opens to the outside of the building. Okay. The best is basically facing behind or facing areas where nobody works or nobody stays on the outside. Okay. Other than Tailors, basically, if you go to shopping malls, depends. I don't think this is in Malaysia on the left. Right? This is quite unique. I would say this is quite a clever way of integrating the exhaust fan, right, in a building. Okay, so it is incorporated in the design. Okay, it formed part of the. I'm not sure if this structure forms part of the roof structure. I believe so, because basically there's a glass roof on top. Okay, so this structure basically is needed to support that glass roof, and at the same time, the opening or the holes within the structure looks like a honeycomb structure. Okay, is used to place the exhaust fan. So in a shopping mall, in an atrium, normally this kind of fan, this exhaust fan, serves for the purpose of smoke extraction system. So when the fire occurs, fire happens inside the room, so and then there is smoke, right? So the smoke will be extracted through this exhaust fan, okay, on the roof. So another view is this is a different building. Okay, sometimes the fan, the exhaust fan, is placed just next to the atrium. So I believe the one on the left, okay, on the left side is basically the glass roof, okay, the skylight for the atrium, and then next to the atrium, inside the atrium, basically there are some grills, openings. The grills, exhaust air grill on the side. So basically, when fire happen, the fan will be turned on, and it would extract all the smoke to the outside. Okay, and then it is something like this. I'm not sure if this is the same building, because the atrium looks the atrium of the roof of the atrium looks more or less the same. It's just a pitch roof atrium. Just imagine that this thing sits next or outside this space here. So basically, the exhaust air grill is located somewhere inside the space, and then when fire occurs, so basically the fan will be turned on, and then it would take out the smoke from the atrium, right? And then bring it out to the atmosphere. And at the same time, you can see here there are I'm not really sure though whether this is for aircon or for mechanical ventilation. Most probably for aircon. Okay, so at the same time, you can see the aircon nozzle, the diffuser is placed next to the exhaust air grill. Okay, types of mechanical ventilation system. The last one is balance or combined system, right? So the first one just now I already mentioned, you have supply system. The second one is exhaust system. So the third one is combined system, where basically you have both system at the same time. Okay, you have exhaust system and you have supply system at the same time. Okay, so the supply system supply fresh air, and then the exhaust system basically extract stale air using fan. So both using fan, right? So basically, fresh air doesn't come in through the openings, but it gets in the building through the fan because of the suction of the fan. So normally used in a very enclosed space where you cannot provide opening at all. Right? Normally in a cinema, theaters, a sports center, basement, attic, crawl space, and so on, where you cannot provide opening for ventilation at all. Okay. So, but for a house, maybe it's not common in Malaysia to use this system. Okay, normally it's in overseas lah. But in Malaysia, we don't really use this kind of system. Usually we use either one. The most common system in a house in Malaysia is exhaust system, right? But this is how it looks like when you have a balance or combined system. So the fan, you have one fan. I'm not sure whether this come together, or I think this one, yeah, this is one fan, this is another fan. You only choose either one, so you don't use both at the same time. Or it depends. Maybe this one for supply, another one is for extract. Okay, but you can see in previous drawing, you have the fan at two different locations. Right, and then here you can actually put the fan at the same place. Okay, let's say here in overseas they have basement they have utility room, huge utility room normally located at basement. They have basement, and then they can put the fan inside the basement, and then the fresh air is supplied through ducting, okay, and then distributed through the ducting into the room, into all the spaces, and then at the same time you have the exhaust fan actually sucking the air, especially from the toilet, and then brings it out to the atmosphere. Okay, so in this case, basically, you can see that the supply system is actually used for the bedroom, Okay, and the exhaust system is used for the toilet and this kitchen. Okay, so not necessarily use this the both system for the same room. Okay, so you can choose lah, which one you want to use supply, which one you want to use extract. But basically, you have both system at the same time. So components involved in mechanical ventilation system, you have fan, filter, ductwork, fire dampers, and diffusers. Okay, so please remember these components. Fan, as you know, is a device for impelling, or basically to take in or bring out the air through the inlet point or ducting, forming part of the distribution system. So forming the most, I would say, the most significant part of the distribution system or the mechanical ventilation system. So without fan, there's nothing. You just have the ductworks. That's it, right? But you cannot expect, even though if you have a ductwork, if you have ducting, you cannot expect the fresh air to get into your house without a fan. Okay, because in the end it's just like natural ventilation system. So it depends on the external air. Okay, it is unpredictable. Okay, the function is basically to remove hot, humid, and polluted air. Okay, I think from the beginning we have discussed about this. What the fan, what was the function of the fan? Another function is basically to bring in outdoor air to either cool the people or cool the building, and then to circulate indoor air at those times when the indoor air is cooler than the outer air. So those are the function of the fan. So here you can see the different kind of fan. These three things are all fan. So the one at the bottom probably more or less is similar to the one in the toilet. Just now I show you, right, the image of the Taylor's toilet. Basically use this kind of fan. So basically the fan, the propeller or the device, the fan is inside here, and basically it exhausts, the air comes out from this opening. There are three types of fan: propeller fan, axial fan, and centrifugal fan. So propeller fan is quite common. This is the one that you normally see in the kitchen or bathroom. So the difference between all these fans is actually on the blade, right? So for propeller, normally the number of blade is lesser compared to axial, and then the tilting of the blade itself also is much lesser than axial. Later on, you can see the difference between propeller and the axial fan. So the main purpose of propeller fan is for free air discharge on wall or window, commonly used without ducting. So normally when you want to use ducting in your let's say in the kitchen, in the toilet or the kitchen, you don't really use it with this propeller fan, but perhaps with a different kind of fan. Okay, so it can remove large volume of air, but not allowing air to be forced through long duct. Basically, air from anywhere inside the space is sucked through that point. Okay, it gets to the point where the fan is located. But if you have ducting, when you turn on the fan, so the air inside the room basically gets to the opening inside the ducting. Okay, it doesn't go straight to the fan, but it goes inside the ducting. There's a pros and cons with that. Low cost of installation and quiet. Okay, depends also lah. I think the older version or yeah, maybe the older version of the fan can become quite noisy lah, or maybe after you use the fan for after a while, then it can be quite noisy, especially when the dirt's already accumulated on the fan blade. Then it can become a bit noisy compared to when the first time you install the fan. Okay, I think that I think I bought an exhaust fan last year or last 2 years. The new one is much silent compared to the previous one, to the old one. Yes, in terms of installation, it's quite low cost. Okay, because the cost of the fan itself is not that expensive, and then you only need the fan. You don't need other components. You don't need ducting, everything. Which actually there's other costs involved, like if you use ducting. So that's why it's low cost. And then usually found in small or medium industrial building, toilet and kitchen. Already mentioned earlier. Okay, the second one is axial fan. So as you can see, basically axial fan consists of impeller. We call it impeller lah. So it's not like yeah, normally for a fan we call it blade, fan blade. But so this is called impeller. Of aerofoil section rotating inside a cylindrical casing. So this is another main difference lah, of axial fan compared to propeller fan. So axial fan, it comes with this kind of cylinder. So it's inside the cylinder, and then if you look at the blades or the impeller, it's actually more than the propeller fan. And then the tilting of the blade also is more than the propeller fan. So the air flows through the fan in the direction of parallel shaft. Okay, so basically it gets in from here and then goes out from here. More or less the same as propeller fan now. But it creates like a jet. How to say? So the amount of air getting into the fan is basically much more, much faster compared to the propeller fan. And you can see, you can normally find this axial fan normally in basement, right? Basement car park. I think even in tailors also we have this kind of axial fan, or in the tunnel, right? I think at the end of this lecture slides, right, there's example of this. Okay, the final one is a centrifugal fan. Okay, centrifugal fan efficiently move large or small quantities of air over a wide range of pressure. It consists of impeller which revolve inside a casing shaped like a scroll. So basically the blade is inside this thing. So it's like a long impeller. Okay, so like propeller fan is quite flat. Okay, but this one it looks like a scroll. It's inside the this casing here. And then the main difference of this centrifugal fan compared to the other two types of fan is the way how the air is brought into the fan. Okay, so like normal fan, the air comes from this side and then goes out to the other side. But for centrifugal fan, the air comes in from both sides, from here and from here, and then the airflow, right, is blown like a 90-degree angle. So it gets from here and then it goes from here. So it's like 90 degrees. So that's the main difference of centrifugal fan. And then because of the size of this centrifugal fan, it's normally quite big. So you need a base, okay, for the fan. So it can be like a frame, normally just a frame like this. So you can see that there's a frame here. And here also same, you can see the frame here. Right, here also you can see the frame. So basically the air gets into the fan from this opening. Then here basically it gets from this side. I believe there are like filters on here. Okay, so the air gets filtered, okay, before it is taken out. So it can be either way. It's either you bring depending on the system that you use. If you use supply system, then fresh air gets in here and then it is supplied to the room. Okay, basically this part here is connected to ductworks, and then the ductworks bring the fresh air into the spaces. But if you use exhaust system, then it's the other way around. So basically the rotation of this of the fan determines whether it's supply or exhaust. So if it is exhaust, basically the air inside the room gets into this part here and then taken out from this side. So I believe this is how it works. This one I'm not really sure whether it's supply or exhaust. Okay, Okay, another component is filter. Depending on what kind of fan you use. Okay, I believe if you look at the exhaust fan not you normally found in your house, maybe there's no filter at all. Okay, just the fan, and that's it. But as you know, the purpose of filter, the function of filter is basically to sift the external air before releasing into the room. Okay, and to trap and prevent dust, smoke, bacteria, etc. from entering the room. Okay. But without the filter, then basically you just breathe in the polluted air. If the air outside the room is outside the house is polluted, and then you just breathe in the polluted air. So that's why filter is very important. Then different type of filter is used for different application. Okay, there's plastic foam, glass fiber, metal sheet, corrugated paper. You can see here there are different kind of filters, right, for different function. Usually installed at the inlet grill. Okay, so the air from the outside coming in here filtered first before it is blown to the space. Ductwork. Basically, the use of ductwork is for you to supply or basically to exhaust or to bring out the air to a specific space or place. Okay, without the ductwork, basically like I mentioned, so you have the fan point on the wall, then you just bring in the air from the outside and directly into the room. That's it. Okay, you don't channel it to a specific space or place inside the room. But with ductwork, basically you can channel the fresh air depending on the system. If you are using supply system, so you can use you can bring the fresh air and then you can channel to the specific directly to a specific place lah. Okay, and then if you use exhaust system, also the same. So you can take up the air from the specific spaces like toilet or kitchen and directly bring it up to the atmosphere. Okay, so that's the advantage of using ductwork. Okay, it comes in mainly three different shapes, three different section. Round section like this, flat oval. Okay, flat oval is I think this is quite new lah. I mean, I've never really seen this, or maybe it's not really common to be seen. But this is flat oval, so the bottom part is flat and the side is actually curvy. Okay, it's oval shape. And rectangular section. This is the most common type of ductwork. So even in tailors, also you can find one. Made of galvanized steel, aluminium, stainless steel, carbon steel, non-metallic material, fiber reinforced plastic, and fabric. Right. So these are all steel, galvanized steel, aluminium. They look more or less the same. But here, this one is fabric. Okay, fabric or plastic. We say, right? Sometimes they use fabric, sometimes they use plastic. Right. I think I've seen this type. I'm not sure if you have seen this, but normally you can find this kind of ducting, ductwork in a huge space like not to say auditorium lah. It's like exposition mall, like expo mall, like MIAP Sedang, right? So MIAP's in Sedang. So I'm not sure. I'm just saying lah, but that kind of space you can find this this type of ductwork. So the next one is fire damper. Okay, fire damper. Of course lah, I mean, referring to the name. Okay, as the name suggests, it relates to the fire protection system. All right. So it is used when you have ductwork, and basically this damper is placed inside the ductwork. Okay, it's either inside inside the ductwork. Okay, so whenever the fire occurs, the purpose or the function of this damper is actually to prevent, okay, to stop the fire from spreading from one room to another. Okay, just imagine that this is the opening. the opening of the for the ventilation. So let's say you have two rooms, one room here, another room here, or like this lah. So you have like 3 different rooms here, right? And then the rooms are connected with this ductwork. Okay, so basically the ductwork basically passing through all the rooms through to the so basically the supply air is here. The supply air is here. So basically it the rooms are connected. I mean the ductworks are connecting the rooms. So basically, when fire occurs, let's say in the room in the middle, so the fire and the smoke can enter the ductwork through the diffuser, okay, through the opening of the ductworks, okay, and then if let's say there is no fire damper, then easily or simply the fire can travel from this room to another room, because without that opening, okay, let's say there's no opening, just the wall, so the fire basically cannot enter the room next door, okay, but with the ventilation duct, basically the fire can enter through the ventilation duct, okay, the fire or the smoke. So basically how the fire damper works, in normal time, so this thing is folded up here, right? It's like accordion lah, if you know accordion, right? So it is when you compress the accordion, so this blades here, right, is folded, and everything is fixed on top of here, and then there's a sensor or a fuse link or something. So when it gets to a certain temperature, so the fuse link would actually break, and then it would release the damper to close the ventilation opening like this. So it will stop the fire from spreading to the room next door. So there are different kind of damper. Some are like this, some are just like a swivel blade. Right? So basically it's just right in the middle here. So when the fire occurs, it just close, something like that. Okay. You don't have to worry about that. As an architect, basically, you don't really have to worry about what type of damper system to use, right? But just for your understanding lah, on the fire protection system of your building. And then finally is the grill and diffuser. So grill and diffuser basically located at the edge of the ductwork where the air is released into the room. And also, maybe I forgot to put it here. One is for air to be released into the room if you use supply system. But another one, if you use exhaust system, basically the grill is where the air inside the room enters. Right? So in this case, basically this image shows the ceiling, which I believe these are air conditioning diffuser. Okay, this smaller one is air conditioning diffuser, but this bigger one is actually for exhaust air, right? So it's actually slightly different between the aircon system and the mechanical ventilation system. Okay. Oh, sorry. There are a few more slides. Okay. So this is some consideration, some things that you need to consider when you want to place the mechanical ventilation. Okay, whether you want to place the fan or you want to put the ductworks. Not necessarily for basement, because basement basically is there is no ventilation. Normally there's no ventilation at all. So that's why mechanical ventilation is very important in basement. But how you place it also is very important. Basically, as an architect, you just need to incorporate maybe the position of fan in the elevation as well as in the plan. So something like this, right? So if you look at this plan, you can see that the position of the supply air and the supply fan and the exhaust fan should be at two different side or two different wall. So if you put the supply air on this wall, if possible, try not to have the exhaust air on the same wall. let's say here. Okay, I'm going to show you how why you cannot do that. So in this plan, you can see that one is placed right at this corner, another one is right at that corner, and then you can see that how the air flows from the supply air opening, supply air fan, to the exhaust air. So basically, it distribute the air. I think to most of the spaces, okay, in the basement, with the aid of this jet fan, this axial fan. Okay, this is the axial fan. Basically, it makes the air travel faster from one side to the other side. Okay, but if you look at the lines here representing the air, it flows to most part of the basement. Okay, so it flows nicely. So the same goes to a house lah. So if you want to put supply air, supply fan, exhaust fan, it should be in different location. Okay, don't put it side by side. Okay, next to one another. Okay, so this one is without ducting. Okay, you only use the supply fan, exhaust fan, and the axial fan. And this one is with ducting, with ductwork. So you have like a huge fan on one side. Okay, so basically what happens is it takes in the outside air from here, gets into the ductwork, and then distributed through the diffuser here. Right? And then from this side, there's another fan on the other side, exhaust fan, pulling out the air inside the basement, okay, through the grill here, exhaust ductwork grill. So the polluted air in the basement parking is captured. Okay, it's taken from this grill, and then it's taken out to the atmosphere. Okay, so this is what I mentioned earlier. Why you cannot put the supply fan or the exhaust fan at the same position. But in this case, basically, it's just exhaust air. The entry is through opening. Right? There's no supply air fan, so just normal opening. And the exhaust air is the exhaust fan is located on at the corner here. But you can see that the flow of air, okay, from the opening to the exhaust fan, it just flows like that. So what happened is because so it doesn't really carry the smoke, the dirt, whatever, from the basement and then into the outside of the building. Okay, so basically the smoke. You just imagine that when you turn on your car, right? The smoke from the car, from the exhaust, would accumulate in the basement. Okay, which is very dangerous because the smoke contains carbon monoxide and so on. Okay, which is very dangerous. So this is the one of the impact of poor ventilation in a building. So that's why the position is very important. So this is a good example of a good position. This space, this parking lot, if you remember, you compared to the previous one is much smaller. So you don't need the axial fan. You just need a natural opening where your car enter from. Then just exhaust fan on one corner. So even for this one also, it's maybe not too good, but then compared to this one, this is much better. Only certain part, only small part of the parking is not covered. Okay, but the rest are all, I think, all good. Okay, end of part one. Okay, end of my lecture for mechanical ventilation. So the next one is on air conditioning system. But before that, need to take a break. Need to go to the toilet. Okay, you guys can do so as well. Okay, I'll be back in 5 minutes. All right. Okay, I'm back. All right, so I think let's go to the next slide. You can see my screen, right?
Yes, sir.
Okay, thanks. Okay, so basically the air conditioning system is the lecture for air conditioning system is divided into two parts. Okay, today I'm going to cover the first part, which concerns more on the aircon system for small and medium-sized building. And then for next week, I'm going to cover the second part, which concerns the air conditioning system for large buildings. Okay, because there are some differences between this system, but the basic principle will be the same. If you understand the basic principles, basically, it's already good enough. For example, like how the air conditioning system works, and basically, in practice, architect is not the person who decides on the type of air conditioning system to be used. Okay, of course you need to discuss with the mechanical engineer, M&E engineer, right? And then they can suggest, or you can also suggest what kind of system. And then normally the M&E engineer would decide on the system to be used. They would propose the best system to be used. But as an architect, maybe you need to provide sufficient space for the placement of all this component. So that should be incorporated into your design, right? So that's why you need to know about the system as well. All right. Okay, so the definition of air conditioning system, okay, is different from mechanical ventilation. Okay, so basically in ventilation, you just distribute the air, right? From the outside, you bring into the inside, and then from the inside, you remove the air to the outside. Okay, circulates the air inside the space. But for air conditioning system, it involves a lot more control. And then it involves the elements of temperature. Okay, in ventilation, you cannot control the temperature, so whatever it is, okay, if the air from the outside is hot, then you would bring in the hot air from the outside to the inside. But for air conditioning system, that's the most important thing. I mean, the important factor why you use aircon in the space or in a building. Okay, so the definition, it can be the air conditioning system can be defined as control of temperature, humidity, air cleanliness, and air movement and heat radiation with mechanical means to achieve human thermal comfort. So basically, the end goal of the air conditioning system is for human thermal comfort. So basically, that's the most basic uh, factor for using aircon system. Okay, but as you know, aircon is not only used for human comfort; it's also used for other things. Okay, so like other factors for using air conditioning system. Okay, number one you already I already mentioned. Number two is for performance. Okay, for performance of workers and also machinery. Okay. I think nowadays, even as students, not only workers, but also for students, right? Just imagine your studio, there's no aircon. I'm not sure. I think even right now, also the aircon issue has not been resolved, right? But I think back in, I think 2013, 2014, 15, right? I think the aircon problem in tailors is much worse. Okay, it's very hot in the studio. We cannot control the temperature. So in the end, it actually have some impact to the students as well as as the lecturers. So you can't really work productively, okay, because because it's very hot. You cannot work comfortably. Okay, so in the end, actually, it is affecting your productivity in a way, right? And also for machinery, some machineries, because it produces heat, so you need aircon to cool it down. Okay. Um, so you use aircon for health, okay, for health reason as well. okay, because it prevents smoke because of the filter provided in the aircon. Okay, it prevents smoke, dust, everything. Okay, so that's why you use aircon. And finally, for to maintain certain equipment, especially computer equipment, electronics, right? It cannot be too hot. For example, like, do you know what is the image on the bottom left? Anyone knows what are those things? Guys, any idea what those things are? Is it a cabinet? Sorry? Sorry?
Are they servants?
Servant? Sorry, I cannot really hear. Come again? But it sounds like that lah. Server, basically it's a server room lah, right? Server room or data center, that kind of things lah. Okay, so server room where your data, online data is stored. Okay, so this kind of equipment, okay, computer equipment, electronic equipment require a very not to say very cold lah. I mean, it's a certain temperature need to be provided, okay, for that kind of equipment, electronic equipment, computer equipment, because if let's say the temperature goes more than the allowable limit, then the equipment will be broken. Okay. So factors related to human thermal comfort. Okay, human comfort. We are talking about human lah. Of course, like machineries, electronic equipments. There are some factors related to that. Okay, but because we are human, right? So we are more concerned about the factors related to human comfort. Okay, so basically what you see here are those things that most of them are those things that you can find in the remote control of your, if you refer to the aircon in your house, right? So if you take remote control, basically you can control all these things, okay, except for maybe humidity lah, relative humidity. So you can control air temperature, okay, that's the most basic thing for using aircon. Humidity, depending on I think certain like a high-end aircon, maybe you can control that as well. Okay, but basically what it means here is it brings in certain moisture like I mentioned earlier. So you need certain moisture level in the space, okay, to maintain the humidity inside the space. And then air movement, okay. So I'm not sure if you have ever control the air movement using the remote control, your aircon remote control in your house, okay. But I'm telling you that yes, you can control the air movement, the direction of the airflow, okay. Because as you know, in the aircon in your house especially, there are blades, right? If you look at the unit, the indoor unit, you can see the blades. So you can control the movement, the direction of the blades, so to control the air movement. And then air purity. Air purity is basically relates to filtration system, filter system. So if you don't know, basically the air conditioning, the aircon that you use in your house comes with a filter. Okay, so if at any time you with the aircon at your house you don't feel cold anymore, then maybe the first thing you should do is to check the filter, and then you can clean the filter yourself. Okay, how air conditioning system works? Basically, aircon system involves 2 cycles. Okay, basically how it works is by removing heat from the air inside the room and releasing this collected heat into the outdoor. Okay, so that's how it works. Not only maybe before this you think that how when we talk about how air conditioning system works, probably you would say, oh, it just bring in cool air. Okay, so the aircon basically produces cool air. That's it. But basically how it works is it slowly absorbing the heat, okay, the hot air inside the room, and then it is actually being released to the outdoor. Okay, so all this happen in 2 cycles, which is refrigerant cycle and air cycle. So for whatever type of air conditioning system that you use, doesn't matter whether this is for small building or for a room, and whether it's for a large building, okay, or a complex of building, the cycles remains the same. So you have 2 cycles, refrigerant and air cycle. The refrigerant can be for a normal aircon that we use in a house. It's actually the refrigerant is made of gas. Okay, so if you have seen maybe your parents or maybe you yourself, you have called the aircon contractor, right, to maybe do maintenance of your aircon. Maybe you have seen them injecting some gas, okay, into the aircon pipes. But for a larger air conditioning system, it uses water, okay, as the refrigerant. And then the second part is air. This is very important also, because without the air cycle, then you cannot actually bring the cold air into the room. Okay, the coldness is already there within the refrigerant cycle, but then without the air cycle, there's nothing happening. Right? You don't bring the coldness to the space. Okay, so I'm going to show you how what I mean later on. Okay, so the first one is the refrigerant cycle, where a process to remove heat from one place. It is actually a process to remove heat from one place to another. Okay, heat inside a room is transferred through the evaporator. Okay, evaporator is basically the one part of the one component of the refrigerant cycle, and removed to the outside air through a condenser. So this is another component. Okay? So you just need to remember this, like evaporator and condenser. Evaporator basically absorb heat, and then condenser basically release heat. Okay, something like this. So I think later on you can read this, the detailed explanation, because what happened during the refrigerant cycle. So the refrigerant in this case is gas. Okay, gas is compressed. Okay, gas is compressed and it becomes liquid like water lah. Okay, and then as it liquefies, it would release a large amount of heat from within the gas. Okay, so this is where it releases the heat lah. Okay, and then as the pressure of the liquid is lowered, okay, as the pressure of liquid is lowered, it becomes a gas again. And then in that case, basically it absorbs, okay, during the process of changing state from liquid to gas, it will absorb the heat, okay, from the indoor. Okay, it absorb the heat from the indoor air into the gas, and it brings it to the condenser. So basically this part here is evaporator. So the evaporator is basically facing the indoor, and then the condenser facing the outdoor. So like I mentioned earlier, evaporator absorb heat, condenser release heat. Okay, something like that. Okay, this is how it looks like more clearly. Okay, heat is transferred from inside air to the refrigerant through the evaporator. Okay, so this is evaporator. But why the arrow is going to this side? Basically, this is already the air cycle. The arrow is actually referring to the air cycle, but here we are talking about refrigerant cycle. The refrigerant cycle is you can see the thicker arrow here, the red and blue arrow here, down here. So the most important part that makes the refrigerant cycle happen is the compressor. Okay, so it looks like a piston here lah, to represent the compressor. So it compresses the gas. Okay, so from here is actually gas. In the state of gas, it compresses, becomes liquid, and then it goes here to the condenser. It releases, the fan basically blows over the condenser, and it releases heat. It transfers the heat from refrigerant to the outside air, and then it goes back to here. And then this is the expansion valve. Basically, it controls the amount of liquid, the amount of refrigerant Yes, anything? Oh, okay, so I thought you cannot hear what I'm saying. Um, and then it goes back to the evaporator in a form of liquid, right? And then when it gets into the evaporator, basically the fan would blow the cool air, because right now basically the refrigerant is cool already. It's already cool, and then the fan actually blows the cool blows over the cool coil, and that's why you feel the coolness coming from the aircon. Okay, but at the same time, the heat inside the room is absorbed. Because actually when the if you look at the aircon inside your house, right, there is a like the one horizontal um, diffuser, or not to say diffuser lah. I mean the where the cold air coming out, right? You know what I'm talking about. So from that part, you feel the cold air. Basically, what happened is the fan inside the aircon blows over the evaporator. Then that's why you feel the cold air. But at the same time, maybe this part you don't really see. But then normally on top of the aircon in your house, I'm looking at my aircon now. There's opening on top of the aircon, and basically the heat or the air inside the room is uh, is brought in through that opening on top. Okay, you don't see it here. Okay, this is how your icon looks like lah. If you exclude them, so this is what you can see in the aircon. Okay, components in the refrigerant cycle, evaporator. This is the most important thing. The evaporator is basically this one. Okay, it's like a coil. Okay, this is a coil, and then this is like a fin that helps to make the air cooler much faster. Okay, um, as already mentioned here, basically what happened is the blower. This is the blower. This is a fan actually. This is the fan used in the indoor unit of the aircon. Right, the fan looks like this. It doesn't look like any fan that you have seen before lah, I believe. Okay, it's like in a scroll shape. The air blown over the surface of this evaporator is cool. Okay, so basically what happened, the air gets from the top, okay, and then blows over the evaporator, and then it comes out from the bottom part lah, where you see where you feel the cool air, right? Then the second one is condenser. Condenser is located in the outdoor unit. As you know, I believe all of you have aircon in your house, right? So you know that you have the you have the indoor unit and outdoor unit. So the condenser is located on the outdoor unit, right? So the purpose of the condenser is to reject heat absorbed by the evaporator. So the heat is absorbed on the inside of the space, and then it travels through the pipe. There's a pipe, right? If you don't know, basically your aircon got uh, copper pipe connecting the inside and the outside. So the heat actually it travels inside the pipe, so it brings the heat from the inside unit, indoor unit, to the outdoor unit, which is the condenser. Compressor. Okay, compressor normally located together with the outdoor unit, next to the outdoor unit. This is a diagram of the outdoor unit. So you have a fan, and then you have the coil, basically the condenser coil surrounding the fan, or maybe in front of the fan, and then the compressor is actually next to it. Expansion valve. Okay, expansion valve is basically this is where you control. Okay, when you adjust the temperature in the remote control, basically it adjusts the opening of this expansion valve. So it brings, it controls the amount of liquid refrigerant into the evaporator. Okay, so you don't have to understand how it works. Okay, basically just talking about the components involved. All right, so the second one is air cycle. Okay, but for the aircon that you normally use in a house, the split unit system, okay, you don't really see a complicated air cycle. Basically, the air gets on top of the indoor unit, and then it blows again over the evaporator, and then gets into, basically the air is recirculated but filtered now. And then but in the larger system, like this one is the system is a system used for for large building. So we call it plant system. Okay, centralized plant system. There is component. One of the main component is AHU. Okay, I believe if you went to some buildings, you have seen like one door labeled with AHU or air handling unit. Okay, basically what's inside the AHU is a fan. So it's a fan and the coil, the cooling coil like this. But the air cycle is actually the process to distribute treated air. Treated meaning that it is filtered as well as it is already blown over the cooling coil or the pipes, okay, the refrigerant, and basically it's already cool and filtered. So the air cycle basically the air cycle system and component basically distribute this cool air from the AHU to the room, right? Okay, I don't have to mention, basically it's the same thing, right? Okay, distribution of air can be either through ducts or chill water pipes. Basically, mainly through ducts. Like this chill water pipes is basically not the distribution of air. Right? This is still distribution of refrigerant. Okay, because this something wrong here. Heat inside the room is removed and slowly the internal air becomes cooler. Basically, the concept is the same as the air cooling principle mentioned earlier, right? So as the room is cool, at the same time the existing air inside the room is absorbed into the outlet here. Existing air is absorbed here, right? And then it will be blown over the filter. So at the same time, it will absorb the heat inside the refrigerant, and then at the same time, the fan would blow over this cold refrigerant, and the coolness can be distributed to the room. So other components required for air cycle, blower fan. Okay, this is how it looks like inside your indoor unit aircon. Okay, this is a blower. You cannot really call it a fan lah, because normally a fan you have blades, right? Flat blade like that. So this is like a scroll shaped blower lah, to propel the air for distribution. Okay, so these are the different kind of fan. Basically, this topic is quite related to the mechanical ventilation earlier, right? So you have learned about the different kind of fan used for mechanical ventilation, but basically the same type of fans are used in the air conditioning system as well. And then the second one is air filter. Okay, this is what I'm talking about earlier. Basically, there are filters in your aircon, in your house. Okay, so you yourself also can actually clean the filter. It's not that difficult. So you just need to open that front cover. Okay, and then you can easily take out the filter, and then you can clean yourself. Okay, save like what, 120 ringgit for aircon maintenance, but of course you need to maintain your aircon as well. Other components required for air cycle, like I mentioned, this is for larger system. For centralized system, you need air handling unit. So there's a room. You need a room to place this AHU. So of course, like the name of the room is labeled AHU, air handling unit. But what's inside the AHU room is something like this. So this thing, right? So inside this metal box here, there's a fan. Okay, this is ducting connecting to the spaces, to the room, and then another ducting to actually channel the indoor air from the room back to this AHU unit. And then inside here, there's a pipe. You can see this blue pipe here. This blue pipe is actually the chill water. For larger system, they don't use refrigerant gas, but they use chill water. Right? I think if you do the assignment, right? Assignment 1, if you visit the building, you can see the pipes labeled with CHWR, okay, which is short form for chill water return, chill water supply, CHWS and CHWR. Ductwork and diffusers, more or less similar to mechanical ventilation, but the difference is it distribute cold air and then it is connected to this. Let's see, you just imagine this number 1 here. So it connects to the pipe, to the ductwork. Okay, so just imagine on this side here, the AHU is located next to this room, this whatever workshop or lab. So just next to it. So and then from the AHU, it blows cool air into the space. Okay, and then at the same time, there's another pipe. I'm not sure whether this one is supply ducting, or if not, the interior air, the air inside the room is actually sucked again into the AHU through this grill here. Okay, so the air inside the room is sucked, gets into the AHU through this grill, then brings back to the AHU, filter, whatever, and then blown over again using this ducting. Okay, other components, clean air intake. Yeah, so this one can be in the larger system. You have the pipes connecting to the outside of the building to take in some fresh air from the outside. Like this. Okay, so you have opening connected to the ducting, air conditioning ducting. So the fresh air gets into here, and at the same time, inside this ducting, basically the air inside the room is circulated. Okay, it's circulated inside the space. Okay, through the ducting, filtered, and then blown over the evaporator, and then it gets back to the spaces, and then the cycle goes on and on. At the same time, the fresh air will be introduced slowly. I mean, so basically, when it returns back to the space, it is actually a mixture of fresh air and the recycled air, circulated air. The types of air conditioning system. What time is it now? Oh, yeah, 15 minutes more. Okay, types of air conditioning system. Basically, there are 4 different types that you need to remember. And today I'm going to cover just 2 types: room air conditioner, or sometimes we call it window unit, and split unit air conditioning system. Okay, the one that we normally use in our house. Okay, first one is room air conditioner. It's the simplest form of air conditioning system. I'm not sure if you have seen this, but I think it's quite popular in the 80s, before 90s lah. Okay, 90s and before lah. Maybe early 90s and before that. Okay, it looks like this. So everything comes in one like oven shape. Oh, oven. Yeah, it looks like oven, but it's not oven. It's window unit aircon. So it comes in one package like this. Okay. Usually it is installed at window openings or wall. So if you have window, then you just plug into the window opening, just like that. Or if you don't want to sacrifice your window, you need to make a hole on the wall, and then you put it in. Okay. But maybe that's a bit difficult to do lah. Okay, to make a hole on the wall. So so everything is in this unit. So it can be divided into 2 components, two compartments. Sorry, the room side and the outdoor side. So what you can see here is the room side. Okay, where the evaporator, where the blower is. Then the other side, at the back, this is what you see. So this is the outdoor side, where the condenser, everything is here. But the principles is the same. Okay, it still has the evaporator, it still has the condenser, refrigerant, expansion valve, compressor, everything. But it comes in one unit. But the split unit, that's why we call it split unit, because it comes in 2 units. But all the other components are the same. The various parts of this aircon can be divided into refrigeration component, air circulation and ventilation component, control system component. Yeah, I've already mentioned this earlier about refrigeration. The component is the same: compressor, condenser, expansion valve, and evaporator. And how it works, you can refer back to this slide number 6 later on. I'm not going back to that slide. But the main thing is how it works. The heat from the room is absorbed into the refrigerant and transferred to the condenser. So on the right is basically the indoor part. So on the left is the outdoor part. Okay, so the cool refrigerant blower basically blows over the cool refrigerant, and you can feel the cool air inside the room. And then at the same time, the heat inside the room is absorbed into this refrigerant, and then it is brought to the condenser, and then at the condenser, the fan blows over the condenser, so it releases the heat. So this is the cycle. Basically, the refrigerant cycle is like that. It moves from the inside to the outside, something like that. Air circulation and ventilation. It's nothing like the AHU, whatever I mentioned earlier. But what happened in the air circulation, basically, there are two sides here, right? Inside, this is inside the room. The one is outside the room. So there are two parts of air circulation. So what happened inside the room? The air, the existing air, is absorbed because when the blower rotates, right? When the blower rotates, basically it draws in, it sucks in the air from inside the room through there's an opening on the side or in front. It gets into the this part, and then it is blown over on the other side. So when it is blown over the other side, it is actually blown over the evaporator. So that's why you can feel the coolness. Okay.
Hello, sir. Sir, you lag out, sir.
Yeah, sir, we
Sorry.
cannot. Yeah, we lost you.
I cannot hear you.
Hello.
Hello.
Can you hear me now?
Yeah, now can.
But you
What's
are
the last?
lagging.
What's the last point I talk about? Huh? What's the last thing I talk about? Cannot remember. Yeah. Are you listening to me or not? Oh, sorry. Hey, can you hear me or not? Hello.
Yes, sir.
Okay.
Yes, sir.
So what was the last thing I talked about, Jesse? Is it the window unit or what? How long have I been frozen?
No, it's just for like few seconds only.
Okay. So I just continue now, right? Okay, so okay, this is how it looks like from the inside of the room. So basically the air inside the room is filtered. There's a filter behind this thing, filtered, and then it
Sir,
is actually,
you're not on the slides.
oh, okay. Really?
Yes, sir. You're not on the slides.
What
You're
about now?
on Teams. You're
What about
still,
now?
Can already.
Okay. Okay, so basically this is what I'm talking about. This is what you see in the room. This is the indoor part of the window unit. So the air inside the room is sucked into this panel here. This part over here, there's a filter here which filters the the existing air. And then the coil is actually inside here. So as the air is sucked into the this compartment, it is actually the heat is actually absorbed by the evaporator, and then at the same time here there's the blower actually blows the cool air, okay, basically from the same evaporator. And then the next part is control system. Okay, this is similar to the earlier control system that I mentioned. You can control the air temperature, you can control the flow rate, okay, the direction of airflow, things like that. Okay, the next one is split unit air conditioning system. Okay, this is one of the most common one, especially for smaller, for a small space, for a house, a small space or a small building. Okay, this is very common. There are some reasons for using it because of the silent operation, elegant looks, and then it's quite economical. Okay, and then you don't have to make a hole on the wall. Okay, compared to the window air conditioning system, you need to make a hole or you need to sacrifice a window. So for this split unit, basically you need to make like a few inch hole on the wall just to pass through the pipes, and that's it. Okay, you can connect the indoor and the outdoor unit. Okay, it consists of two units, outdoor unit where the condenser is, and then the indoor unit is where the evaporator and ignore the issue. And it's connected by copper tubing. Okay, so this is how it looks like the whole system. At the same time, you need to have like a drain tube, because as the system operates, right, there will be condensation happening. The water will be dripping from the evaporator, so that's why you need to have this tube, okay, to channel water. If you realize, probably you have seen this, no? So normally at the back of the indoor unit, you can see a pipe to channel in the condensated water. Yeah. Okay, so I already talked about this earlier. So these are just the components inside the outdoor unit and the indoor unit. This is the copper tubing. This is where the connection is. The copper tubing is connected from that point to the indoor unit. Okay, so this is the most important part. So you need to understand the different kind, because there are various kind of split unit air conditioning system. The one that you use in your house is just one type, but there are two other types. Okay, so the first one is split unit without outside air, or we call it ductless split, meaning that you don't introduce any fresh air from the outside into the system. So as I mentioned earlier, the air is circulated inside the space. Okay, even though it's circulated, but because of the filter, it actually filters the existing air. So technically, it is cleaner, so it should be cleaner than the previous state, right? So that's why from time to time you need to clean the filter, okay, so that you maintain the. We can make sure that the air that you breathe is clean. So normally used for small room or area, and then the types of indoor unit. So these are the three types of the most common one, especially in Malaysia, is the one in the middle and on the left. So the one in the studio is something like this, right? And then the one at your house is normally the wall-mounted type. Okay, consideration of placement of indoor unit. This is especially if you use the wall-mounted type. So you need to place it at a location where the air can be distributed evenly throughout the room. So that's why in the middle, not to say if let's say you are using the cassette type, maybe right in the middle of the room. If you're using the wall mounted, then it should be in the middle of the wall like this. Okay. So you can see here the lighter green is priority location number 1. Priority location number 2 is the darker green. So that's where you should put it, right? The wall-mounted indoor unit should be located not too close to the roof. It should be about 2.4 meter from the floor, because if it's too close to the roof, basically it is actually cooling the roof, because you know the roof is quite hot. Okay, you are cooling the roof more than you are cooling yourself. So that's why it shouldn't be put too high. But I believe the aircon installer, they know where to put it, right? So the indoor unit should be accessible easily, so that you can conveniently clean the filter every fortnight. Look here, every fortnight. Okay, every 2 weeks by right you should clean your aircon filter and the whole unit. This is for maintenance. Okay. Consideration of placement of the outdoor unit. It should be placed in the open space, as preferably on terrace. Okay, or maybe it can just be hung on the external wall like this if there's no space, there's no terrace, or it can be placed on. If it's placed on terrace, it should be placed on like there's blocks like this lah. Okay. There should not be any hindrances in front of the outdoor unit. Okay, you shouldn't put this outdoor unit facing the, like, let's say that you have a balcony, and then the balcony is actually made of half wall. Okay, so there's no like grill or whatever. So basically the air is blocked by the wall, so you shouldn't put it there. Easily accessible for carrying out maintenance work of the compressor, condenser, and so on. Okay, the second one is split unit with outside air. We call it ducted split. Okay, so if you look at the name, you know lah. I mean, when we say ducted split, meaning that you need to use ducting. Okay, you need to use ductwork together with this system. So sometimes some of the existing air is recycled and recirculated and mixed with fresh outdoor air. I think later on I'm going to show you another. There's a drawing I'm going to show you. So larger capacity compared to the ductless split system. You can see this is the condenser unit outside the outside the space. Okay, it's huge. It's bigger than the normal outdoor unit. So evaporator can be placed inside a suspended ceiling or in a closet. So depending on how you design it. So if you put it under the ceiling, then you need to have a proper ceiling height. Okay, floor to floor height. That one you need to check if you're using this system. So how short can your floor to floor height be if you want to use this system? Okay, so normally used for like auditorium, small auditorium, things like that. Not normally used in a house. Okay, this is what I mentioned earlier. The compressor is placed here, right? And then you have the refrigerant piping, refrigerant lines goes to the indoor unit. So these are the indoor units. And then at the same time, you can see the ducting. This is for fresh air intake. So fresh air intake gets into the system, and then at the same time, this is the existing air inside the room is taken into the split unit, into the indoor unit, and then mixed with the fresh air, and then the conditioned air or the treated air is distributed into the room. Okay, similar goes to this part. So you can see here two different types of ductworks. This one is like more rigid, like steel ductwork, and this one is more flexible. Okay, ductwork. Okay, this is how it looks like. But this example is for a house lah. But in Malaysia, we don't use this for a house. I'm not really sure why. Maybe because of the control. It's a bit difficult to control the temperature for different spaces. Okay, and then the last one is variable refrigerant flow, VRF, or variable refrigerant volume, or VRV. So I think probably some of you have maybe have heard this term VRV, right? So it stands for variable refrigerant volume. Okay, this is we can see this is like a more sophisticated type of split unit compared to the traditional split unit. So in traditional split unit, the one that we use in a house is one-to-one split system. So you have one indoor unit and then you have one outdoor unit. But for VRF or VRV, it is also known as multi-split system, where you can have one outdoor unit and inside you have several indoor units. It can be more than 8 units, 8 units or more. Okay, depending on the size of the condenser. So the bigger the condenser, the outdoor unit, the more units you can have on the inside. So types of indoor units, more or less the same as the traditional one. You can have floor standing, wall mounted, cassette unit, and also ducted unit. So it can be used with ducted unit is like this. So this is the ducted unit, the one that you use with ductworks. Okay, particularly popular because they require less outdoor plant compared to the conventional system. So you just imagine, in this case, you have like 1, 2, 3, 8 indoor units, but only 1 outdoor units, which is quite huge. You just imagine that if you use traditional split, so you need to have this. When you have 10 indoor unit, you also need to have 10 outdoor unit. So you need to lay down, right? You need to arrange the outdoor units at one. If you have space, maybe you can arrange them lah. But then if you don't have space to put the outdoor unit, then it might look very ugly lah, your building, right? So when you have too many outdoor unit, so this is a good option to avoid that from happening. Types of VRV or VRF system, there are 3 types. Okay, master and slave system, zone control units, and variable refrigerant volume VRV system. Okay, the first type, master and slave system. What you need to understand, what you need to remember is there is one master controller. Okay, imagine that you have 10 indoor units, but one out of 10 of this indoor unit is is paired with the master controller. So whatever you control, whatever variables that you change in the master controller, so the other 9 units would just follow. Let's say you adjust the temperature, previously 18, you increase to 20. So the other indoor units would just follow whatever control that whatever that you change, right, in the master controller. Okay. The second one is zone control units. Zone control units basically, you can control the indoor units individually, okay, but at any one point, you can only have either cooling or heating. So if the system use cooling, especially overseas, you have a heating system, right? In Malaysia, we don't really use heating system for building, right? So you have cooling only. So all the indoor units only cools the building at the same time, but you can adjust that you can control individually. And then finally, the VRV, variable refrigerant volume. Okay, so able to provide total versatility, and each indoor unit may cool or heat independently of each other, even though they are connected to the same outdoor unit. But individually, you can have like one cooling, one heating, one stop. Okay, so things like that. So you can do whatever you want with the individual indoor units, right? Okay, planning for placement of split system. Earlier, I've already mentioned about the where to place the indoor unit and where to place the outdoor unit, right? So here, we just want to talk about the relation of this split system with your design. So nowadays, if you look at the modern terrace house or modern bungalow design, right, you can see that quite often you can see this kind of louvers in front of the house, okay, on the side. But actually, one of the purpose of that louvers, okay, other than it looks quite, sometimes it looks quite nice to have louvers, right? But it is actually not necessarily, normally it's not to bring in fresh air from the outside to the inside, okay, because the louvers is actually located in front of the wall, so there's no like fresh air coming in from the louvers. But most of the time, the purpose of the louvers is actually to hide the outdoor unit. Okay, so that's one of the method that you can do in your design to hide the outdoor unit, because it doesn't look nice, right? If you look at your design and then you can see you see the outdoor units, it's not nice actually. But that's what happened in buildings until recently, when an architect design a building, they rarely consider the placement of the air conditioning system. Okay, the outdoor units, where to put the outdoor units. Okay, on the drawing board, okay, in the computer, or the elevation looks very nice, very sleek, and then when it gets built, and then the building occupant install aircon, then it doesn't look nice anymore. So that's why your role as an architect, your role as an architect is to consider this thing. Okay, when you know that when you design a terrace house and later on you come, the residents would install aircon, and then you need to think about that earlier. So where are they going to put the aircon, the outdoor unit, and then how it can be hidden from the side, and so on. And then another method is to place it on the flat roof. Okay, even though the main part of the main roof of the building, main part of the building is covered with a pitch roof. Okay, but maybe you can save like a certain area, maybe above the toilet. Okay, with a flat roof. Okay, so one of the basically when you have a flat roof in your design, you can place the outdoor unit on top of the flat roof. Okay, with that, basically you don't really see the outdoor unit from your eye level, especially when you stand on the ground. You look up, you don't really see the outdoor unit. Right? Okay, so basically that's all. It's already 10:10. Okay. All right, so that's all for today's lecture. So after this, please go to Times. So basically, I have posted some questions, okay, on Times. So during this tutorial hour, preferably during this tutorial time, this 2 hours time, please answer the question in the tutorial sheet. Okay, so please answer the questions I posted on Times. And then you need to type in your answer, and you need to submit through the link given on Times. All right. So you may Any question? Yeah.
Study. So tutorial.
Yes.
You are giving them
Rizal.
exercise.
Yes. For today's tutorial, I'm just giving them exercise, like exam lah. How they would answer in exam, and maybe some of the question would appear again in the exam. So who knows? Okay. So for today, you guys just answer the question, and then submit through the submission link. Okay, Rizal.
Okay. So I would like to talk about the site visit letter. Yeah. So I already uploaded the format. Yeah. Mr. Dik, can you make me a presenter?
Okay. Macam mana? Sorry.
Go to the participant.
Go to the participant. Okay.
Find my name, and then click at the 3 dot beside my name and make me a presenter.
Too many Muhammad here. Sekejap. Okay.
Okay, done.
Belum. Okay, done.
Okay, so this is how the format looks like. Can you see the screen? Yeah.
Yes.
So you need to change the dates here. So you need to provide the name of person in charge, and then the name of the companies or building, and you need to provide with the address. Yeah, this is official letter. Yeah? Need to have all of this. Okay, and then you need to fill in your name, the name of your group members, IC number, and also student IDs. Okay, once completed, you need to send it to me, and I will give you this letter. Can you see my screen?
Currently, I'm looking at your desktop screen.
Wait. This one. So I will cut and paste your information in this letterhead, and then I will sign, and I will give it back to you. Send it back to you. Okay, is it clear regarding the format? Okay.
Okay, sir.
So, sir, does that mean for the people, right, we need to contact the building management itself, then we can only write it down?
Yes,
Or...
you need to get permission. You cannot just go there and show the letters. Sometimes people they don't like that. Yeah. So you need to get permission. You need to email them, get feedback from them. If they allow you to come, okay, you can go . So maybe when you email, you can email together with this letter. I'm worried that when you walk in, people don't want to entertain you, and you will get scolded. Yeah.
Okay, noted, sir.
Okay. And then one more thing. Okay, I already mentioned here. Yeah. Can you see my screen? Mr. Adib. Yeah. Sorry. Group. Mr. Adib group is group 1 until group 10. My group is group 11 to 19. Okay. And then my group, please join this group channel. Okay. How to see, how to know where's your group? Please check this link. Yeah. The one that you write your name here. Okay. Already put here, Mr. Adib. And my name.
So for my group, I need to set the channel first, right?
You set your channel inside it and give them
Okay.
the link so for them to join. Okay, and one more thing. Okay, 3 okay lah, 1, 2, 3 maybe backup, But this one, until 11, give some to your friend lah. You are not doing more than one, just one. Yeah. You are not doing 2 or more than 2, just one building. So the rest give to your friends.
I think it's just a practical joke.
Practical joke, okay lah. Should laugh lah about it. Okay. 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 Please avoid to choose the same building lah, especially for those under the same tutor. Okay. Is it clear? Okay. In terms of type of building or suitability of the building, you can discuss with your tutor. If your tutor say okay, you can proceed. Okay. So my suggestion is to find a medium-sized building, not high-rise. Yeah. So if you still want to do high-rise, okay, you can do high-rise, but prepare to do extra work lah, because high-rise got quite big system. Yeah. So you need to report all in the report. Yeah. Okay.
So can you repeat that in case, just in case people miss what you say?
Okay. I would suggest a medium-sized building that consists all the services. Yeah. Mechanical ventilation, air conditioning system, mechanical transportation, and fire protection system. Okay. But if let's say you still want to choose high-rise building, so prepare to do extra work. Yeah. High-rise building, the system is quite complicated. Okay.
Yeah. Okay. The medium size is how big?
Usually medium size is maybe 3-story, 4-story building.
Okay, got it, sir.
Okay.
Thank you. Yep.
I repeat, if you still want to do high rise, okay, but you need to do extra work, no shortcut. Shortcut means, okay, sir, I want to choose this small portion, part of it, half of the building. No, you need to show all. Okay.
Understood, sir. Yep.
Anything to add?